So today we are going to talk about dimension. So first of all, let's talk about derived quantities. So derived quantities are formed with the help of fundamental quantity. Okay, so let's take an example to make it clear. I'm gonna take an example of velocity, which is displacement over time. Um, the arrow, we will talk about that in vectors, but it's important to write the arrow, but it's not that necessary when learning about dimension, but I'm going to write it anyway. So the top portion, the displacement is a length, so it could have a unit of meter, whereas the bottom portion is of time, so it could have a unit of second in SI system. So the unit will be meter per second. Hence, derived units are the combination of fundamental units, and fundamental quantities are used to form derived quantity. Now, let's talk about dimension one more. So, the power to be raised, the power to be raised on the fundamental quantities, um, quantities in order to represent given. Let me write it more clearly. To represent given quantity is called dimension of that quantity. So let's take an example which will make it clear. So let me write the topic, which is dimension, and I will write here note. You can write here dimension as well, but I will write note. Okay, so for example, let's take force. So force, the most common formula that you might have heard is from Newton's second law of motion, which is F equals to ma. You can write acceleration as m velocity upon time, and velocity can be written as m1 by t dot l by t. Here we are not representing them by vector because it does not matter right now. We are just trying to see what will be the dimension of force. That's why we are writing it in this way. So here we can write this as ml t minus 2. So m meaning for mass, l meaning for length, and t meaning for time. So if you have to write the dimension of force, it will be represented by f in the brackets. So now the dimension will be capital M L T, and according to the definition we have written power to be raised on fundamental quantities. So the fundamental quantities are mass, length, time, temperature, etc., etc. We don't write temperature, etc., etc. right now because I will tell you the reason pretty quick. But for now, let's look at this. So here we have mass, and as you can see, the power raised to the mass is 1, and L is 1, so length is 1, and time is minus 2. That's the power raised. So thus we can write, so thus the dimension of force is 1 in mass, 1 in length, and minus 2 in time. I hope that's pretty clear. So now let's talk about dimensional formula. So first of all, we have to talk about what is dimensional formula. So when talking about dimensional formula, first of all, let's write the definition. It is the expression that shows which fundamental which fundamental quantities are involved and in what ways to form a given physical quantity is called dimensional formula. So forget about the definition. Let's go back here. We just found that the dimension of f here is mlt minus 2. I don't have to say 1 1, so if you don't say 1, it will be considered as 1. So now here f equals to mlt minus 2. So here f is force. So here in dimensional formula we can write the dimensional formula of force. A force is equals to mlt minus 2. So you can write 1 or you may not write 1. It does not matter. It's the same. So now the next thing we are going to talk about is dimensional equation. If dimension are written in equation, then it will be known as dimensional equation. I think dimensional equation. I just wrote the spelling wrong, so I was very confused. Okay, so it is a equation that relates given physical quantities with its dimensional formula. With its dimensional formula is called dimensional equation. It's basically like an equation but for dimensions. So for example, we know f is mlt minus 2. Here you don't need to have only one equation, which means that you don't you can have multiple terms for in the equation. Okay, so I could have va ma, so in the brackets I could have written ma. It would be the same thing when we are talking about dimensional equation. So this was it for today's video. In the next video we are going to talk about some examples of dimensional formula, so stay tuned for that one.